Hi everybody, I thought we'd do a quick screencast on how to graph a function. So generally speaking, you're given a function that looks something like this and you want to make a graph of it. So the first thing you do is create a table of values, which is over here at the moment. Then draw some axes and plot some points, remembering to label the axes correctly, and we'll talk about it a little bit here. Draw a smooth curve through the points. That's really difficult on a tablet. I'll do my best and then I'll just use a graphics program. And then observe the critical points on the curve and see if there's any more points that you should really look at to make your graph better. So here's our first function, y equals x squared plus 1. It's a parabola that's been moved up by 1. And here are some points here that I found by substituting into this. So negative 2 squared is 4, plus 1 is 5. Negative 1 squared is 1, plus 1 is 2. 0 plus 1 is 1, 1 plus 1 is 2, 2 squared is 4, plus 1 is 5. So that's how we got these values here. Gave us the coordinates negative 2, 5, negative 1, 2, 0, 1, 1, 2, and 2, 5. And with my dodgy hand, I plotted the points on here. So negative 2, 5, that's this one. Negative 1, 2, that's this one. 0, 1, that's this one. 1, 2, that's that one, and 2, 5. So there's all the points plotted, and then I drew by hand a nice neat curve through the points. I didn't connect it with a ruler because it's not straight lines, it is actually a curve, and you can see here I didn't do so well. And then when I did that, I had a look to see that I'd gotten all the critical things. I can see that my turning point's at 0, 1, my y-intercept is also at 0, 1, and it has no x-intercepts because it doesn't cross the x-axis. Example 2. This one was a bit more difficult, so I've put a bit more detail into it. I've got y equals x squared plus 2x minus 3. And I started with negative 2, negative 1, 0, 1, 2, because I didn't really know what the graph looked like. And substituted negative 2 into here. So negative 2 squared plus 2 times negative 2 minus 3, minus 1 here, minus 1 there. Simplified it here, came out with minus 3, put it into my table. Did the same for minus 1, put minus 1 into the equation, found the values, simplified, substituted it into my table. 0 is nice and easy. 0 plus 0, take 3 is negative 3, goes into the table. Did the same for 1, did the same for 2. Ended up with that table of values, ended up with these points. But you can see here that I haven't got the other x-intercept, so it's worth now going back and finding that just to check how good my graph is. And if I put negative 3 into here, I'll end up with negative 3 squared plus 2 times negative 3, take 3. And if I'm correct, and my graph is right, I should get 0. So 9 plus 6, no, 9 take 6. Take 3 will give me 0 as expected. Now I can put the last point on my graph. Should check to they've done all the right things, got all the arrows, the x's and y's. And just to show you where it's gone up there. And there we have it, a nice neat graph of this equation. And again, as expected, it's a parabola. I think that's all I wanted to show you on this, so thanks everyone. Oh, there was one other thing. Over here, before you actually draw your axes, it's worth looking at what values you want to put on it. So you can see here the minimum value of x is minus 2, the maximum is 2. I'm going to fit them all x, y's. Now look at the y values. The maximum is 5, the minimum value is going to be 1. So I need to have a graph and axes that's going to allow me to draw the graph itself. So before you draw the axes, it's always worth looking at the table of values to say, well, what axes am I going to need? And that's why we do the table of values first. The other thing that was interesting to look at is where are the y values symmetrical? Because if you can find out where they're symmetrical, then you've found your turning point. So I can see on this side I've got a 5, on that side I've got a 5, on this side I've got a 2, on that side I've got a 2, and there's a value in the middle. That middle value is going to be your turning point. Similarly with this one, the table's not symmetrical, you can still find the symmetrical values. They're symmetrical around negative 1, 4. We've got the same values, same y values on either side. And if you look here, there's the turning point, which happens to be this point here. And that's all I wanted to tell you. Thanks, everyone.